Okay, hi everyone. Today we're going to work on something called solving a system of equations. And what that means is a system could be more than one equation. So 2, 3, or 4 equations. And we're going to try to find a point where they all agree. Okay. So example is you and a friend want to meet. But there's a lot of variables like where you're going to meet, when you're going to meet. So you guys have to meet at the same place and time so you can meet. Because if they show up to the mall at 2, but you show up to the mall at 4 and you left already, you guys aren't meeting, right? So let's go ahead and give you guys an example what a system of equations is. So when we're drawing lines, so that's solving a system of equations using graphing. Oops. Okay, that's our goal today. We're going to solve a system of equations using graphing. And then when I say system, I just mean more than one equation. Now, let me first show you something that is a system of equations but doesn't have a solution. So imagine if this is you on a graph, okay, x and y plane, and your friend here is walking across the street, okay? If you and your friend are walking on a parallel path, will you guys ever meet up? Okay, big question, big idea. Will you guys ever meet up? I could go on forever, but if your friend never crosses the street, or you never cross the street, you'll never meet up, right? It's just going to be like you waving across. Right? And parallel lines will never meet up. They'll never intersect. So they'll never have a solution. No common points. But if I tilt this line slightly, ever so slightly, the lines will eventually cross. And that point where they cross is my solution to this system. Meaning it's my solution to these equations. It's the only common point that these have to share. Now let me go to give you guys an example of this. Let's say y is equal to 4x plus 4. This is one equation. And then I have another equation. And just like our solar system where we have more than one planet, we have two equations here. And the question is, will these lines ever meet? Will they meet? And when I say they meet, they have the same x and y value. Can I find an x and a y value that would work for both of them and make them true? Now let me give you one that for sure is wrong. If I start guessing and checking, if I say if x is 0, okay, let's plug in 0 here. If this is 0, then y is 4. Let's go with that. If x is 0, y is 4. That's my y-intercept. What if I put x is 0 over here? If x is 0 here, then y is negative 5. So is 0, 4, and 0, negative 5 a common point? No. What if I plug in 1, 2, 3, 4, 5? Well, it would take me forever to guess, and this would be a waste of our time. So I'm going to show you guys one of the easiest methods, though it's not accurate because our graphing skills are not perfect. But let's go ahead and graph these two lines and figure out where do they meet. So I'm going to graph the first line in blue, call this in blue, and then I'm going to graph the second line in red. Okay, blue and red, just so you guys can see that. So x's and y's. And my y-intercept, my m is 4 and my b value is 4. My y-intercept is 4. 1, 2, 3, 4. I'm going to try to graph this the best as I can. Try to keep my my dashes separated. Put a dot. And then we're going to go rise over run. Rise 1, 2, 3, 4, and then run 1. Okay, I'm hoping that my tick marks are about even. And then let's take a ruler here, because the ruler would really help me here. And then I'm going to draw a line. All right, let's see. That's not bad, right? Okay. Okay, so that's one line. Let's graph the second line now. Or we said we're graph this in red. And my y-intercept for the second line is negative 5. Negative 1, 2, 3, 4, 5. And my x value is, okay, and my slope is negative 5 over 1. M is negative 5. Our b value is negative 5. So negative 1, 2, 3, 4, 5, and over 1. Okay, so you can see that these two lines intersect, and they meet at a common value of that. Now, if my graph was drawn probably a little bit better, the answer here is, it looks like it's going to be, I know the answer already. It's going to be negative 1, 0, okay? It's going to be negative 1, 0. So let's see if this point here, which is kind of roughly okay, it's not like the best graph in the world, right? But let's see if negative 1, 0 fits. So for my first equation, y equals to 4x plus 4, and my second equation, y equals to negative 5x minus 5, we're going to check, does negative 1, 0, does it work for both equations? The idea of this solution to the system is that, hey, this is where the lines meet. So we're saying it's going to meet at negative 1, 0. And I want to show you guys that this is the only point that is true for both statements, meaning that this gives me a line that's equal. So if I plug in 0 here, if I plug in negative 1, y equals to negative 1, darn it, I'm sorry, 4 times negative 1, 4 times negative 1 plus 4. Is this going to be the same as y is equal to negative 5x times negative 1 minus 5? Okay, let's see if they will have the same x and y value. So y is equal to, this is negative 4 plus 4 is 0. Y is 0 here. And on the right side, y is equal to 5 minus 5, which is y is 0. So if x was negative 1, my y value would be 0. And if x was negative 1 on my right side, my y value, hey look, they have the same common point, which is my graph. Now, us solving by graphing is one of our easiest ways to solve a system of equations, because it just involves us drawing two lines, and we're used to drawing lines by now, hopefully. Graph the y-intercept and then the slope, and then looking at where they meet. If I do this on Desmos, Desmos will do a so much nicer job. If I do this on Desmos, to just show us, we have y equals to 4x plus 4. My second equation, y equals to negative 5x minus 5. And you can see that these lines will meet, and they will meet at negative 1, 0. So are there any other points on this graph that we can say that they have in common? So again, when we say there's a solution, it means it's a common point that they both share. Hey, did you see your friend at the mall? Yeah, we were there at the same time and at the same place. When you guys go to the mall, or when you guys used to go to the mall with your family, you guys might all split up. And you might say, meet back here in front of Old Navy at 3 o'clock. That's a common point that you guys all should share, no matter which way you go. And that's what we're doing. We're finding that common point that these guys share. Now, what if I change my graph? So if I change my graph, you can see the solution changes depending on where I stop. So every single time, we will always have a solution, but the problem with this solution is that their intersection point changes. Right? See that? So two lines will always ram into each other, but at what point? And that's for us to discover. See, so if I change this or change any of these properties, the intersection point then changes. And our goal in Algebra 1 is to discover where those lines meet. Okay, so let's try a different question. Okay, let's try this again. My new equation is y is equal to 6x minus 4 and y is equal to negative 2x plus 4. Okay, I want to ask you if this solution is going to work. If is 1 comma 2 a solution for the system? So now I reverse it. I'm going to give you the answer and you tell me, does 1 comma 2 work? And then we're going to verify this by graphing. So does 1 comma 2, if I say y is equal to 6x minus 4 and y is equal to 2x negative 2x plus 4, would 1 comma 2 work for both these lines? So let's go ahead and plug in our x. Y is equal to 6 times 1 minus 4. Why? Because x and y, my x is 1. That's an easy way of starting. Y is equal to negative 2 times 1 plus 4. Okay, so y is equal to 6 minus 4 is 2. This is 6 minus 4 is 2. And over here on the right, negative 2 plus 4 is positive 2. Hey, look, they both have a common 1 comma 2, 1 comma 2. So they do share this answer. So yes, 1 comma 2 is a solution. Well, if I spin this around and I say that's now verify this by graphing. Okay, so on IXL you'll do both. You'll do one by plugging in the points like we're doing now, and you'll graph it to see if the lines meet. So there are no new skills here really. There are no new skills. We're just working on graphing like we've been working on before. So let's go ahead and graph these two lines now. I'm going to graph this in red and this guy in blue. Okay, let's go ahead and start graphing this. Y is equal to 6x minus 4, so negative 1, 2, oh, sorry, wrong color. 1, 2, 3, 4, put a dot. That's my y-intercept, okay? This equation here is y equals to 6x minus 4. My m is 6 and my b is negative 4. So my slope is 6. That's pretty strong. 1, 2, 3, 4, 5, 6, and then over 1. Oh, I totally ignored my line. And then my second color will be y is equal to negative 2x plus 4. And then my m is negative 2 and my b is 4. So over here we're doing positive 4, 1, 2, 1, 2, 3, 4. And my slope is negative 2 over 1. Negative 2, 1, 2 over 1. Hey look, they share that common point. I can see it already. Okay, so what's that point? The point, as I'm guessing, is probably looking like 1 comma 2. And 1 comma 2 is the answer that we previously checked. Okay, that's pretty much it. That's this whole lesson. Okay, so I'm gonna do one more example of this, just so that we're kind of on the same page here. So, what if the line equations are not written nicely like in slope-intercept form? What if I have to manipulate it? What if I have to change it ever so slightly? Well, let's look at another equation that allows us to practice that. Okay. So what if, let me try something. Okay, here's our problem. So what if I give you guys not y, x plus 2y is equal to -4, and y is equal to 3 over 4x minus 7. So my first goal is probably just rewrite that. You can either graph it using using its intercepts, right? Because that's in standard form. But let's rewrite it so we can practice the skill. X equals to 2y. Darn it. X plus 2y equals to -4, and we're gonna subtract x to both sides. 2y is equal to -x minus 4. Divide both sides by 2. Y is equal to, I'm going to write this as -1/2 in front because it's an invisible 1. Invisible 1 here, right? Minus 2, because -4 divided by +2, negative divided by positive is a negative. So we have two lines to graph now. I'm going to graph this guy and graph this guy to see where do they meet. So let's graph we'll call this one blue and call the second one line red. Okay, let's set up our table, our chart, our graph. -7, oh my gosh, that's going to be a tough one. -1, 2, 3, 4, 5, 6, 7. All right, -7. And our slope is 3 over 4. My b value is -7. So I'm going to write as 1, 2, 3, and I'm going to run 1, 2, 3, 4. Put a dot. Draw my line. Let's graph our second equation in red. My m value, my slope for my second equation on the right is -1/2, and my b value is -2. So my m value is, my b value is -2, and my slope is -1 over 2. 1, 2. And if I actually do it again, -1 over 2, we actually have a meeting point nicely right there. So what point is that? That's going to be 1, 2, 3, 4. That looks like a 4 and a -4, -2, -4. Okay, that looks like -4, +4, -4. So the hard part here is making sure that you know where your points on the graph are. And those are your tick marks. Graph paper is great, but you don't need it. You don't need it for the most part. Okay. Let's just double check our answers. Let's see if this is a point on both graphs. So if I plug in, let's go ahead and plug it back into these equations. You could plug into this equation if you want, but I'm going to use the original just to show you guys. If I plug in 4 plus 2 times -4, do we end up with -4? So 4 minus 8. So 4 minus 8 is -4. Hey, we have -4. This is a true statement. That is a point on my first line. Is it a point on my second line? -4, does this equal to 3 over 4 times 4 minus 7? The 4's divide out, because 4 divided by 4 is 1. -4 equals to 3 minus 7. And yes, -4 does equal to -4. It works for my second line too. Okay, so our whole goal in this lesson today is to be able to graph two lines to say, hey, these lines meet. Now, where do they meet? Because this is what we call the solution. This is the only point where they agree with each other, that the x and y values are in both these equations. Okay, so that's what you guys will do. You guys will graph these equations and tell me where they meet. And that's what the solution is.